Option 1. In this case, the collision occurs here at a certain point here. At a certain point here. So I'm going to assume that this is the collision. At this point here, SA is this whole arc. And SB is this arc. So if I do the subtraction of the yellow arc from this small arc here in green, so this whole arc, which is SA, minus this arc here, so I'm gonna have this arc. And what is this arc? It is from A0, the first position of particle A, to the first position of particle B, which is in fact 240 degrees in radians, which is 4 pi over 3 times this radius r. So the first option at this collision here, SA minus SB will be equal to 4 pi over 3 times the radius. Right? So why is it 4 pi over 3? Because it is 240. All right, so this is 240, guys. This angle here is 240. So if I want to convert it to radians in order to find the arc, remember, guys, the arc is r theta. I cannot put this angle in degrees. I should put it in radians. All right, so this angle is 4 pi over 3 times the radius that is given as 5. Now, what is SA? SA is equal to 0.8 T3 over 6 plus 8T minus SB, which is 2T squared plus 8T. So 8T and 8T will vanish. I'm gonna have 0.8 0.8 T3 over 6 minus 2T squared is equal to 4 pi over 3 times r. So I'm gonna bring this before the equal sign. So 4 pi over 3 times r times 5 is equal to 0. So if I want to find the time here by solving the 3-degree equation, let's go to MATLAB. So I did it in the first section. So yes, this will be P, guys. Right? So this will be P. كده polynomial expression, and then I'm gonna say roots of this P to find the roots. So I'm gonna have 3 roots. 2 of them are complex and 1 of them is real. And of course, guys, I have to take the real root, which is here T is equal to 15.64. All right? So in this case, T is equal to 15.64 seconds. So this is for option 1. Right? Now what about the second option? The second option, guys, I'm gonna assume that the collision, right, occurs here. And this is when A is very small while B is very fast. If this is SA here, so this is SA to the collision, then SB will be much greater than SA. So this will be SB. Okay, so this will be SB and this will be SA. In this case, guys, B is very fast, for example, and A is very slow, so the collision could occur here in this portion of the circle. And in this case, SB minus SA, because SB is much greater than SA. SB minus SA will be equal to what? SB minus SA will be equal to this arc here. Now, what is this arc? It is 120 degrees in radians, which is 2 pi over 3 times the radius Guys, you are with me? You agree with me, guys? All right. So now, guys, in this case, the difference between them will be this arc right here, which is 2 pi over 3 times r. So let's replace this. Now this will be minus 0.8 t cubic over 6 minus 2 t squared minus 2 pi over 3 times r. And r is 5, of course, and this is equal to 0. So if I go to MATLAB, and now I do the roots of this one, right? So that's it. Sorry, guys, this is plus because minus is plus, right? So if I do this, and then I do, so this will be my polynomial, and then I'm gonna do the roots of p. And in this case, I'm going to have 3 real values, but one of them is negative, and I cannot have a negative time, so I'm going to choose both of them, the first two, 14.63 and 2.5. So either you take 14.63 or 2.5. What do you think, guys? In this problem, I have 3 acceptable duration to have a collision: 15.64, 14.63, and 2.5 seconds. Which one should I choose? Why, Sana, I should choose, why, Noor? Yes, why I should choose 2.5 seconds? In fact, guys, I should choose the first time at which collision occurs. So I have to choose the shortest time at which collision occurs. I cannot say, guys, that this is the first collision, this is the second collision, and this is the third collision. Never. Because, guys, after collision, everything will change. After collision, I should do, as we're going to see in the next chapters, I should do the momentum equation in order to find what are the velocities after collision. Right? So I'm going to choose the first time at which collision occurs, and this will be when t is equal to 2.5 seconds. So in this case, guys, the time to collision is 2.5 seconds. All right? Now, if you choose the same origin, like we did in the rectilinear motion, so let's say I'm going to choose A0 as my origin. In this case, SA0 will be equal to 0, right? So, of course, guys, SA0 will be equal to 0. But S0B will not be equal to 0. S0B will be equal to what? So SA, which is 0, SA0, which is 0, plus what? Plus this arc here. It will be equal to 2 times 2 pi over 3 or 4 pi over 3 r. So this 4 pi over 3 will be shown here in S0B. And then you can say SA is equal to SP in order to find the time. All right, guys? So if you choose the same origin, you have to make sure that S0B is no longer 0. All right? But if you choose different origins, which are A0 and B0, then you're going to have S0B is equal to 0 and S0A is equal to 0. However, you cannot say SA is equal to SB in collision. Okay? So the chosen T will be equal to, T is equal to 2.5, so this is my time. And whenever I know T, the question is to find the magnitude of acceleration. So whenever I know T, guys, I can, of course, say that AA is equal to radical AN squared plus 8 squared. All right? So what is AN squared? It's the radical plus 8 squared, and they are both for A, of course. Now I know VA, because in fact, I know T. So I can find VA. A T is equal to 2.5. VA will be equal to 10.5. So VA will be equal to 10.5 at this T. So I know VA, and rho is equal to 5. This is a circular motion. And I can find also AT, because in fact, AT is equal to 0.8 times T, and T is equal to 2.5. So you can find AA. And same goes to AB. VB will be equal to 40 plus 8, which is 18, because T is equal to 2.5. Almost 18, right? It is 2.5074. So VB is equal to 18. So I can find AN, and from AN I can find AB. All right? So that's it for this example. Do you have any questions so far? Quickly, guys, please.